This is a homework problem. In this problem for part A, none of the crates are moving and you want to rank the crates on the basis of the magnitude of the frictional force acting on them. You can solve this the same, well, you can solve part A similarly to how we did the previous problem. Draw a free body diagram. The sum of the forces in the x direction is equal to 0. For part B, the crates are moving, and for this you need new information. So if you read the beginning of Model 2, this is page 57, and it explains to you here how to use the coefficient of friction. If you have kinetic friction, the coefficient of kinetic friction, for which we use the Greek letter mu, and you have the subscript k because it's kinetic friction, times the contact force, which is what we have been calling the normal force. So you have friction between two surfaces. The normal force that between those two surfaces times the coefficient of kinetic friction gives you the force of kinetic friction. So we have the force of kinetic friction is equal to the coefficient of kinetic friction times the normal force. If we go back to page 63, when we did the free body diagrams here, you have two different forces of static friction. So if you're looking for, well, let's pretend this is kinetic friction instead. If you're looking for this force of kinetic friction, because this is from the bottom block on the top block, you would do this force, which is a normal force, because it's perpendicular to the surface of contact. So it would be this normal force times the coefficient to give you this force of friction. And if you're looking for the friction between the bottom box and the floor, it would be the normal force between the bottom box and the floor that you use. You may not have called it a normal force, but it should be normal or perpendicular to the surface of contact. They give you the coefficient of friction here, and when they do this, the first number that they give you in parentheses is the coefficient of static friction. The second number is the coefficient of kinetic friction. If you forget the order, the static friction is not necessarily greater than kinetic friction, but in your book it always is. So the greater number is the coefficient of static friction. Okay, so this is how you find the coefficient of kinetic friction. You have an equation which is similar for static friction, but for static friction, it doesn't give you the force of static friction. Instead, it gives you the maximum value for the force of static friction. So if we rewrite this equation, we would have the maximum value for the force of static friction is given by the coefficient of static friction times the normal force. So your static friction may be less than this, but it can never be greater than this.